we're going to do a little problem that is going to illustrate the fact that in this chapter, how we use our calculator is going to be fundamentally important and different than some of you are accustomed to. And you won't be successful if we don't get you using the calculator the proper way. To illustrate this point, I'd like to just make up a problem. One of Jupiter's moons, Io, has a mass of 8.93 times 10 to the 22 kilograms, and Jupiter's mass is 1.90 times 10 to the 27 kilograms. Io orbits, or Io, I don't know how it's pronounced, Io orbits at a distance of 4.22 times 10 to the 7 meters, measured from the center of Jupiter to the center of Io. Okay, let's assume that we want to find the gravitational force that Io and Jupiter exert on each other. Now, it's a Newton's third law action-reaction pair, so that's why I said the force that they exert on each other. At any rate, we've been talking today about this law, Newton's law of universal gravitation, which says that the force that masses exert on each other, the force of gravity, all masses exert forces on other masses everywhere in the universe, that this force is equal to a constant, g, whose value we're going to learn more about, but where it came from. But the value of g is very small. It's 6.67 times 10 to the minus 11 Newton meters squared per kilogram squared. At any rate, the force of gravity that Newton's universal law of gravitation gives us says that the force of gravity between any two objects is equal to g times the mass of the first object, the mass of the second object, and that is divided by the distance between the objects squared. The distance separating m1 and m2 squared. So let's go ahead and write down the values we have. Big G, the universal gravitational constant, as I just mentioned, has a value of 6.67 times 10 to the minus 11. And let's just put Io first. Doesn't matter the order we put them in. So here's 8.93, the mass of Io, times 10 to the positive 22 kilograms. And then Jupiter's mass comes next, 1.90 times 10 to the 27. All of that is divided by the distance between those two objects squared. So we have 4.22 times 10 to the 8th meters, and that quantity is squared. Now, here's the point I'm trying to make. I think it's probably obvious to you that these numbers are really small, really big, pretty big, and then you square it, it gets really big. And so you can't enter a number like Io's mass, 8.93 times 10 to the 22nd. You just simply cannot enter that straight up into your calculator without using scientific notation. And I think what some people would want to do is simply enter the following in their calculator. You're going to push 8, and then you're going to push decimal point. I'm talking about Io's mass here. And then you're going to push 9, and then you're going to push 3. And then kids want to put times, and then hit 10, 1 and 0, and then they want to hit the caret button and raise that to the 22nd power. Now, you can do this, but it's not the proper way to enter a number in scientific notation into your calculator. Not only that, you just pushed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 buttons, and there's a better way to do it. And there's a proper way to do it. Not only that, but because you're going to then multiply that by something else and divide it by something squared, you actually need to nest this in parentheses to begin with. And now we've hit 12 buttons, counting the parentheses. That's just not the right way to do it. The proper way to do it is to use the exponent button, and I'm going to show you that right now. But just to simplify things, if to do it properly, you would actually only enter 8, and then the decimal, and then the 9, and then the 3, and then you would hit, now on this calculator, you would just hit EE. So you would go 8.93, and then EE, I like to say that stands for enter the exponent. It really stands for engineering exponent, but let's just pretend that the EE button means enter the exponent. So I hit it. And you'll notice that on this calculator, the TI-30, 2 little zeros show up. That means times 10 to the. Whatever exponent you put in means times 10 to the. Now in this case, we just hit EE, and we just put in the exponent, which would be 22. So I do that. That is perfect. If you wanted to now multiply by another number, you'd simply hit times. You don't need to nest it in parentheses or anything. Notice that this is just 7 buttons instead of 12. It gets even more important when you have divided by a large or small number and then squaring. It doesn't, you need parentheses, and the order becomes worrisome. You can make mistakes. Now on this calculator, the way you do the exponent is slightly different. Let me show you that if I may. Remember, the number we're going to enter is 8.93 times 10 to the 22. Let me show you how to do that on a TI-84 or 83 or 87. We turn it on. I like to hit clear. And this number, 8.93 times 10 to the 22, the proper way to do that is 8.93, no surprise there. Then you hit second function. You hit the blue second function button, and notice that right above the comma button, above the 7, there's a comma, that above the comma, it says EE in blue. Again, engineering exponent, but let's pretend that means enter the exponent. So I'm going to hit that EE button. Now on these calculators, a capital E shows up, not little zeros like did on this calculator a minute ago, but this E, which means times 10 to the. Again, now we only need to enter the exponent, which in this case is 22. And that is 8.93 times 10 to the 22 properly. I'm sorry, you do not need to put it in parentheses. You're done. If you wanted to multiply that by, if you wanted to multiply this by the mass of Jupiter, you just hit times and then put in the mass of Jupiter, 1.90 times 10 to the 27. Again, second function, comma, activates this engineering exponent, and you place the exponent, in this case 27, into the calculator. I don't know which calculator you're going to be using. I have a couple other brands here. This type of Casio, there's an exponent button. That's how you activate it. So again, going back to this number that's 8.93 times 10 to the 22, the proper way to enter it on this calculator is 8.93, and then you hit exponent. and the two little zeros show up again, which means times 10 to the, and that is proper. Again, if you just want to multiply by the mass of Jupiter now, 1.90 times 10 to the 27, notice I hit exponent again. That is how it's done. That's 1.6967 times 10 to the 50th. There is no way to enter that number as a decimal. I mean, it's just got 50 zeros after the 1.0, 1.6 in this case. But anyway, this is another Casio that's seen better days, but the exponent button, again, is how you activate using numbers in scientific notation properly. Just because a large number of you have this calculator, let's go ahead and do this problem from scratch using this calculator. So to find the force of gravity, I'm going to multiply big G, 6.67 times 10 to the minus 11, times Eo's mass, times Jupiter's mass. Then I'm going to hit divided by. You can hit enter and get a number, but if you do it the way I'm showing you, you don't even have to do the numerator first. You can just do it as one big problem. So let's do it. So here we go. We have the universal gravitational constant, big G, 6.67, second function, comma, minus 11. That means 6.67 times 10 to the minus 11, and multiply that by the mass of Eo, 8.93, second function, comma, times, which means times 10 to the 22 power, times 1.90, again, second function, comma, exponent is 27. I'm going to hit enter. That's the numerator. And then I'm going to divide by 4.22, second function, comma, 8. And then I'm going to square that. Believe it or not, if you use this exponent button, you don't even have to put it in parentheses. It knows that this is a number. I'm going to talk a little bit more about that in a minute. But now when I hit enter, I am going to get the final answer. And believe it or not, the force that Jupiter exerts on Io, and actually Io exerts back on Jupiter, is 6.35 times 10 to the 22 newtons, which is an enormous force. But there's our final answer to this problem. Again, I did this really to show you how to use the calculator properly. You're going to struggle if you don't use the calculator in this chapter this way. The reason why this is the wrong way to do it with the times 10, caret, and then the exponents, and again, that's why you have to put it in parentheses, because if, let's just say for the moment, you don't put it in parentheses. You think that this is legit the way I've written it, this 10 buttons you had to push. Here's the problem. The calculator doesn't think of this as a number. It thinks of it as an operation between two numbers. It thinks you want to take 8.93 and multiply it by 10 to the 22nd power. And that's actually, it's not an operation. You don't want to do a multiplication problem. I mean, if you nest it between parentheses, it works. But when you have a number that is like these numbers are, they're a single number. They're not an operation. It's really not 8 times this. It's this big. This whole thing is one number. And the only way to get the calculator to realize that it's a number and not an operation between two numbers is to use this exponent button. Again, on the fancy TI-30, it's second function, comma, because that's how you activate the EE button. Thank you for watching that. Let's do some problems.